Hello everybody. So today I'm going to try to explain to you what infinity is. Okay? So let's get into it. What are the fundamentals of existence? Okay? So you have the photon, the antiphoton, contained within the Higgs. Okay? So the photon is kind of like, if you're looking at this red dot, okay, photons from that red dot that I just drew are shooting out every which direction, okay, infinitely, okay? It's shooting out every which direction in the space where matter does not always already exist and is not already infinitely expanding, okay? So that is basically photons, okay? Antiphotons are what are not photons, okay? So for instance, right now, I'm basically absorbing the photons that are being shot out at me. You are absorbing the photons from this red dot that are being shot out at you, okay? In that instance, you are antiphotons, okay? Photons are basically pushing out, antiphotons are basically pulling in, okay? And they're all contained within the Higgs, okay? Which you can think of, you can perceive it to be kind of like a sphere, okay? Is it really a sphere though? No, it's a wave, okay? But I'll get into that in a little bit, okay? So you have photons, antiphotons contained within the Higgs, okay? And everything within the photon is basically the infinite torus, okay? So you think of this as kind of like just a red dot, right? But it's not really just a red dot, because within this red dot and all the photons that it's shooting out in infinite directions, except where photons are not already being shot out in infinite directions by other matter, it's basically infinite, okay? So that's what the infinite torus is, okay? It's kind of like a torus, but rather than just going two directions, it's going in infinite directions, okay? It's shooting out photons in infinite directions, and it's pulling in photons in infinite directions, okay? That's the infinite torus, okay? And then you have the gratis's, which are kind of like, think about it like this. You have the Higgs, which you can think of as spheres, which they're really not. They're accumulation of waves, okay? But they're basically getting infinitely larger and infinitely smaller, okay? Going every which direction, okay? And those are the gratis's are basically the steps between the Higgs, okay? Getting infinitely smaller and infinitely larger, okay? Those are the gratis's, okay? Some people might look at it as like dimensions, okay? Dimensions of a cube, okay? But the thing about it is, whenever you call you call it different dimensions, it gets confusing, okay? Because dimensions are what we use to basically separate length, width, and height, okay? So technically gradiuses and dimensions are kind of the same thing, but it's confusing whenever you try to basically accommodate everything and just call it gradiuses, because then people don't understand what you say. Gradus in Latin means steps, okay? It's basically just the steps of space that separate the different photons, antiphotons, and Higgs, okay? But I'll get into it a little bit later, but it's all pretty much infinite, okay? The only thing that changes relatively is the size of the Higgs, getting infinitely larger and infinitely smaller, okay? Now, another issue is fields of time, okay? They're different fields of time, okay? Everything is infinite within existence, okay? But there are different ways to explain all these different things so it can make sense to the human mind, okay? But there's fields of time, okay? So for instance, a hummingbird, okay? A hummingbird's heart rate is over 1,000 times a minute. Mine is around 100 times a minute, okay? Those are two different fields of time, okay? A tree is on a different field of time than my field of time, okay? The fields of time are all relative to what field of energy they're within, okay? All right, so those are the different aspects to explaining existence, okay? So I went over this in my last video, explaining relativity and the double slit experiment, okay? So within this theory, okay, relatively everything within this existence is infinite, okay? I'm infinite, you're infinite, technically this space that separates me and this wall is infinite. It's all infinite, okay? But the only issue is there's two different aspects to infinity, okay? There's something that's finite and there's something that's infinite, okay? Something that's finite has a beginning and an end. Something that's infinite has no beginning and no end. Something that's beyond infinite has both infinite and finite properties, okay? So for instance, me, I am a conglomeration of photons, antiphotons contained within the Higgs, okay? Which I have both finite, because this energy field that I currently am within my body is finite, but my being, okay, my consciousness is infinite, okay? After I leave this field of energy, my body, I'll go on somewhere else. Who knows where it'll be or where I'll be, but I'll go on, okay? So the double slit experiment, okay? So I explained it in my last video, I believe, but it talks about basically how when they performed the double slit experiment and whenever they tried measuring things, it changed things up, okay? So why did it change things up whenever they did this double slit experiment? And instead of naturally watching things, things changed whenever they tried to measure things, and it created basically wave-particle duality. Okay? Well, the reason for that was because whenever they started trying to measure things, relativity kicked in. Okay? Because relatively, within your existence, you're everything. Okay? Everything. All this that surrounds me, all that is me, all that is within inside of me is me. Okay? Because this is my existence. Same with you. It's your existence. Okay? And I know that's hard for people to kind of wrap their head around, but I'll get into that in a little bit. Okay? So, let me get into the EM spectrum real quick, okay? Okay, so the EM spectrum, I call it the information spectrum instead of the EM spectrum because it basically is information. It's everything, okay? It's infinite, okay? So at the beginning of the information spectrum, you have radio waves, and then you have microwaves, infrared, light, ultraviolet, X-ray, gamma waves. 1, 2, 3, 4, 5, 6, 7. Okay. That's the current electromagnetic spectrum. Okay. Now, what they haven't accounted for in the information spectrum yet is what all basically encompasses this entire spectrum. Okay, begins at love waves, also known as magnetic waves. At the end of the spectrum is entropy waves, also known as gravity waves. Okay? Love waves oscillate at the frequency of right after 10 to 0. Okay? Which is 1. Okay? So they oscillate right after 0. Okay? All the way up to infinity, covering the entire information spectrum. Okay? So they're covering all of these things, okay? Because think about it like this, okay? You have a photon, an antiphoton. The photon can basically be considered love and magnetic waves, okay? Pushing everything out. Now, on the edge of the surface, you have entropy and gravity waves, which are basically pulling everything in, okay? So that's on the surface, that's on the horizon of the photon. It's basically the antiphoton, entropy and gravity waves, okay? And that covers the entire information spectrum, okay? So, with this theory though, everything is infinite, okay? Everything is infinite. The speed of light is infinite. Whenever you're not measuring it, it's infinite, okay? Whenever you're measuring it, relativity kicks in and it's not infinite. You can measure it. It's like 300 million meters per second or something like that, okay? But whenever you're just watching it naturally, it's infinite. It's not limited, okay? And basically, Okay, so this is 0, okay? So what really is 0? Well, if you really think about 0, 0 is not just a circle, it's also a sphere. What is a sphere? Well, it's infinity, okay? So a 0 is really the same thing as infinity. And infinity is the same thing as Trinity. And, you could just keep going and going and going and going and going until it gets larger and larger and larger until it becomes infinite, okay? Because everything is basically connected by a torus, okay? The infinite torus, okay? Now, let's get into how photons and antiphotons are not, contained within the Higgs, are not really particles, but they're waves, okay? So, you look at this, and it just looks like a big circle, right? Or a big sphere, right? Well, it's really not, okay? It's basically a conglomeration of waves, okay? And the best way for me to be able to allow you to visualize that is to think of the Earth, okay? Whenever you look at it from out in space, it just looks like a big sphere, right? But is it just a big sphere? No, it's not. If you account for the water that's on the Earth, it's an accumulation of waves, okay? And if you account for the terrain of the Earth and the vegetation and all that stuff, that's also an accumulation of waves. Just moving in a different field of time than the waves that the water consists of, okay? Do you understand that? And that's all everything is. It's basically just waves, okay? Think about whenever you have a blanket and you put it on you in your bed. You can think of that blanket as like a field of energy, okay? And as you put that blanket on you in your bed and you lay beneath it, well, the contour of that blanket is going to change as you move around in bed, okay? That's the same thing as like a field of energy, is waves. You know what I mean? Okay. So, let's go to the aspect of time. What is time? Well, time is an encompassment of everything, okay? Time is the entire information spectrum, okay? Time is basically, photons are pushing out time, antiphotons are basically pulling in time, okay? So, for instance, me and you right now, you're seeing me because the photons coming from me are being infinitely pushed out towards you, okay? And you are pulling in my photons with your antiphotons infinitely as well, okay? Which, going back into the fields of time, I've said this in other videos, but you and I currently right now are on a different field of time as well, okay? Because you're actually watching this video. What's happening right now is in the past, okay? Because I've already filmed it, I've already edited it, I've already put it on the net, okay? You're actually watching the past right now, okay? We're in two different fields of time, okay? And technically, I'm talking to the future right now, okay? So, But basically you are, this is you, okay? So you're both pushing out time and you're pulling in time, okay? Your photons are pushing out time, your antiphotons are pulling in time, okay? And if you look at Leonardo da Vinci's Vitruvian Man, you know, where if you account for human beings and going every which direction with your arms and legs and things like that, it basically makes a perfect sphere. Because what are you? Well, if you look at it at the fundamental level, you are basically just the photon and antiphoton, which is the infinite torus, okay? Contained within the Higgs, okay? That's all that you are, okay? Looking at it fundamentally, it's that simple, okay? Just a conglomeration of photons, antiphotons contained within the Higgs, which are what? Waves, okay? So let's get into the idea of zero, okay? What exactly is zero? Well, zero is basically an abstract idea of the idea of nothing, okay? But the abstract idea of nothing is even more difficult to wrap your head around than the idea of infinity, okay? Because what is the idea of nothing? It's still something, okay? Everything is infinite, okay? Everything is infinite. Even if you go and you sit on your bed and you just sit there and you close your eyes and you're sitting, even though you're doing nothing, you're still doing something, okay? Whether you call it meditating or whatever, you're still doing something. Everything is something, okay? Everything is infinite, okay? But yeah, that's all you are. That's all that everything is basically a wormhole of time, okay? It's all time being pulled in, pushed out, infinitely, okay? So let's get into the aspect of particle physics, okay? So particle physics, okay? So the smallest particle that we know of is the electron neutrino and the electron antineutrino, okay? The largest is the top quark and the anti-top quark, okay? So if you think about it like this, okay, so let's think about it like this, okay? So because I don't want to write down all the different particles and particle physics. I've done that in other videos if you want to see that. But so at the very center, you have the electron neutrino, okay? And on the outside, you have the anti-top quark, okay? So basically it goes from electron neutrino, and then on the outside, it's basically, on the outside, you can think of it as the antiphotons that on the outside of the photon, okay, is the electron antineutrinos. Then it goes up from particle to particle to particle to particle to particle and antiparticle, 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 okay, until you get to the very top of the particles, which are the top quarks and anti-top quarks, okay? Those are all contained within the hydrogen atom, okay? And everything is infinite, okay? The better our technology gets, the smaller the particles we're going to be able to see, and the farther out in space we're going to be able to see, okay? It's going to be, it's infinite. It doesn't stop, okay? It's basically just a big wormhole of time, which is basically infinite, okay? You're a wormhole of time, I'm a wormhole of time, this wall's a wormhole of time, you know, plants are wormholes of time, you know, that's all it all is, okay? So, let's get into the idea of multiverses, okay? So everything within the universe, within this theory, is a universe, okay? Everything within the universe is a universe itself, okay? That's infinity, okay? And you can get into the aspect of the different degrees of infinity, okay? Because if everything is infinite, there has to be different degrees of infinity to basically separate the, you know, as George Cantor said, the infinity of infinities, okay? There has to be something that separates all the different infinities, you know, which you're infinite, I'm infinite, you know, it's all infinite. But to be able to separate those, there has to be different degrees of infinity, okay? So, like I said, I'm a universe, you are a universe, we are the multiverse, all encompassed within existence, okay? Yeah, so let me get into how it works with our relative field of time, okay? So you have the sun and you have the earth, okay? So the best way that I can explain this is within particle physics, you have the quarks and the leptons, okay, which is what I was explaining earlier, and you have the gluons, photons, and bosons, okay? Basically, the fundamental building block of everything is the photon, okay? That's the fundamental building block of everything, okay? Photon, antiphoton, contained within the Higgs, okay? Which are what? Waves, okay? So you have the sun, which is basically shooting out light, okay? So within all the different gradiuses of space, it's all interchangeable, okay? But you have basically gluons that could be compared to gravity, okay? Pulling everything in, okay? Then you have Z bosons, which could be basically compared to love magnetic waves, okay? So the gluons are basically gravity and entropy, pulling everything in. Z bosons are basically magnetic and love waves, pushing everything out, okay? Then you have W positive bosons, which you could consider light, okay? Which is basically, the sun is basically pushing out light, which is also heat. So W positive bosons could be considered light and heat, and W negative bosons could be considered dark and cold. Okay? So it basically goes back to the idea of the electromagnetic spectrum. Okay? Okay. So let's look at one of the photons from the electromagnetic spectrum. Okay, so we'll go to the light part of the electromagnetic spectrum, and we'll look at one of the red photons. Okay, so outside of the red photons are the antiphotons. Okay, basically pulling everything in. Okay, and the photons are basically pushing everything out. Okay, so this is where it gets to be kind of trippy. Okay, so space, all the black stuff that you see whenever you're looking out in the night sky, that is basically, pretty much for the most part, a conglomeration of an antiphoton. Okay, basically because you can basically think of like this photon. You can basically look at this photon as infinity. And the antiphotons that are basically pulling it out and pulling it in are basically infinity as well. Okay? So that's the trippy thing about it, is all of this that surrounds us, all of existence, is pretty much encompassed within one antiphoton. Okay, within an antiphoton. Okay, I don't want to say one antiphoton because all photons, Higgs are all infinite. Okay. So yeah, that's about it. So okay, the fundamental forces. Okay. So the fundamental forces, you have the strong force, you have the EM spectrum, which I like to call the information spectrum. You have the weak force, and you have gravity. Okay? And this is basically how scientists compare how strong they are. Okay? Strong force is stronger than the EM spectrum. EM spectrum is stronger than the weak force. Weak force is stronger than gravity. Okay? But whenever you start to account for the gradiuses, you start to see that, okay, so this is the outside of our solar system. Okay? This is basically, okay, so the inside of it is basically the sun. And then you have the earth. Okay. So, okay. So you have to look at things kind of from a backwards perspective to be able to actually understand this, okay? So the strong force can be equated with gravity, okay? Which is basically encompassing everything. The electromagnetic spectrum, the information spectrum, can be basically encompassed with the next level. And then you have the weak force, is the next level, and gravity, which is the next level, okay? So you could basically compare this to kind of like, okay, solar system, man, I'm getting caught up. Okay, so the solar system, you have to think about it. Okay, you have to kind of think about it like a wormhole. Okay, so on the outside you have basically gravity, which could be considered as the strong force. Okay, looking at it from that perspective. Okay, then you have the electromagnetic spectrum, which you could see is kind of like what kind of holds the planets and stars and all that stuff together, okay? And then you have the weak force that you could kind of consider as the sunlight coming from the sun and the heat coming from the sun, okay? And then on the very middle, you have gravity, which could be considered the strong force again, because you get to the level of the photons and antiphotons contained within Higgs, which are actually holding everything together, okay? So, yeah, that's pretty much that. It's all basically just a big wormhole though, okay? Everything is just basically a wormhole of time, okay? I've been working on this stuff for a while, trying to explain it so that people can understand it, because in my mind it all comes together, but whenever you're actually trying to put the knowledge into other people's heads, it's hard for them to basically wrap their head around. You know, it's kind of like Einstein with relativity. All he was saying with relativity was everything is relative, okay? There's different fields of energy, which I have a different field of energy than this wall is. You know, I'm a different energy field than this bottle of water is, or you are, but everything is relative to me, okay? So, if I go watch a movie, I might like that movie relative to me. If you go watch that same movie, you might not like that movie relative to you, okay? Everything is basically relative, okay? Yeah. Okay, let me check my camera real quick. Okay, but anyway, like I was saying, it's all just infinity, okay? It's all just different degrees of infinity, okay? That's all that existence is, okay? And I can't guarantee this for sure, but I'm pretty sure that you've always existed, that I've always existed, that all of this has always existed, okay? Mass is finite, but energy is infinite, okay? So, you know, it's all infinite, okay? It's all basically just a big wormhole getting infinitely larger and infinitely smaller, okay? That's all it is. That's all you are. That's all I am. That's all everything is, okay? It's infinite. So, I think I pretty much went over everything. Yeah. Photons, antiphotons, Higgs, infinite torus, Gratis's, field of time. It's all infinite. Okay? It's all infinite. Okay? The only thing that changes is the relative Higgs getting infinitely smaller and infinitely larger. Okay? You know, and people might say, well, this doesn't make sense with them being able to measure the speed of light and different things like that. That doesn't really matter. It really doesn't come into play because whenever you start measuring things, relativity kicks in, okay? And relatively, you're everywhere, okay? This is all of you, okay? This is all of me. This is all of you. You are everywhere, okay? That's relativity, okay? It's all infinite, okay? But yeah, that's pretty much it. That's all that I wanted to talk about today. Yeah, that's pretty much it. It's all just a conglomeration of photons, antiphotons contained within the Higgs, which, when measured, are particles, but naturally are waves. Okay? Because going back to what I was talking about, whenever you look at the Earth from a distance, it just looks like a big sphere. Okay? But is it a big sphere? No. It's a conglomeration of waves. Okay? Water waves are moving a lot faster relatively than the waves are on this wall. You know what I mean? But if you compare the terrain of mountains to the waves of water, they're both basically the same thing relatively. It's just the waves of the water are moving at a different speed than the waves of the mountain. But if you speed up time, the mountains, the terrain and all that stuff like that, it's going to look the same way as the waves of the water, okay? They're all relatively the same thing, okay? And it's the same thing. It's the same thing with the speed of light, okay? Because the speed of light is traveling a different speed within this gratis than it is within this gratis, okay? It's infinite, okay? It's infinite. Same thing with us. You know, compared to the different organisms and different things like that that live within us and live on us, you know, compared to them, our bodies are probably similar to the way the Earth is to us. You know, to us, relatively, whenever you look at mountains and different things like that, they're not moving like waves. You know what I mean? They're staying in the same spot, you know, relative to us. You know what I mean? And I'm sure it's the same way with the organisms that are within us and live on us, okay? Because relative to them, time is traveling at a different speed than relative to us. And I can't say this for sure, but I'm pretty sure that the speed of time is equivalent to size, okay? So the larger something is, the slower that time goes relative to something that's smaller, okay? The smaller things get, the faster the time goes relative to something that's larger, okay? Because relatively, everything is relative, okay? Okay, so for instance, like us, whenever you look at things from the level of the strong force, okay, compared to us at the fundamental level of the strong force, things are going so much more quickly relative to us, okay? But at the level of gravity, well, that's basically within our field of time. So relative to us, the field of time of gravity, things are going much slower than at the level of the strong force, okay? But it's all basically just a big wormhole, getting infinitely smaller, infinitely larger, okay? That's all it is. It's all infinite, okay? So is that everything that I pretty much wanted to cover? I'm trying to make sure that it is. Yeah, I think that's about everything. I think that pretty much covers it. You know, a lot of this stuff, it's theoretical, okay? And a lot of people might say, well, you can't really prove this theory because within this theory, you're saying that basically everything is pretty much infinite. Yeah, well, pretty much. You know what I mean? But we've made previous measurements that have basically pretty much proved this theory correct, okay? If you account for the measurement of the EM spectrum, which now I'm calling the information spectrum, okay? And the measurement of the double slit experiment, okay? And just all those different kinds of measurements, yeah. Basically, all the measurements have pretty much been done to more or less support this theory, okay? That everything is pretty much infinite, okay? You're infinite, I'm infinite, everything is infinite, okay? Yeah, so there's other things that I could get into. I don't want to make too long of a video today, but I think that's pretty much about the extent of it, okay? Yeah, it's all infinite, okay? So I think the biggest thing, this is theoretical, but I think the biggest thing you have to worry about with death is, I don't think you really have to worry about any more of there just not being anything after death. Because there's no such thing as nothing. Okay, that's an abstract idea. Everything is everything. Everything is something. Okay, So, and technically, everything is infinite. Okay? So the biggest thing you have to worry about with death, you know, this is theoretical, like I've said, is that you're going to lose your ego. Okay? And you're going to become something else. What that will be or where that will be, I couldn't tell you, because relatively, it's like I said, you're everywhere. So theoretically, you can go anywhere, you know? And that doesn't, I don't think that necessarily even applies to time necessarily, because technically if within your existence you're everything and you're everywhere, well then you could basically be manifested at any time, any place, anywhere. Okay? And that's infinity. Okay? That's how infinity works. Okay? I just want to make sure I went over everything. Yeah. But that's pretty much it. So I appreciate your time, and I thank you for watching. Okay. I thank you for absorbing the photons coming from me contained within the infinite Higgs, okay? And the infinite photons being absorbed into you and your infinite antiphotons, okay? But yeah, that's pretty much all it is absorbing, emitting, and reflecting, okay? Yeah, so thank you for your time.